Hello, hello, hello. Another lesson by Martin Tutorials. Today we're learning is an introduction to factorial. As usual, I have colorful notes. Of course, colorful makes it more fun, and the other real reason I've run out of black ink, that's a good reason to make it colorful. And my other confession, I tried to do this lesson outdoors, sitting on a park bench with trees. That's a great idea, except it got too windy. I'm holding this paper, it kept flapping, so I had to redo it indoors, which is now obviously. So now I'm going to explain the concept of factorial. Factorial is denoted by an exclamation mark. For example, 3 factorial is shown with 3 and an exclamation mark. And what 3 factorial means is 1 times 2 times 3, which happens to equal 6. Or you can write it as 3 times 2 times 1, depending on your textbook, equals 6. 5 factorial is 1 times 2 times 3 times 4 times 5, or 5 times 4 times 3 times 2 times 1. Okay, and that's simply what factorial means. So what's 55 factorial? 1 times 2 times 3 times 4 dot 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 times 53 times 54 times 55. All those numbers multiplied together, which will give us an enormous number. Anyway, that's factorial. Okay, so 4 factorial is 1 times 2 times 3 times 4, or 4 times 3 times 2 times 1. So what's significant about this factorial that it has a name? The most common usage is it's a number of ways of ordering things. Perfect example, if I've got 5 erasers in front of me and I want to place them in various orders, how many ways can I arrange it? 5 factorial. If I've got 7 people in a line, I want to know how many ways I can order the line. 7 factorial. Another example, let's say I have 11 pencils in front of me. How many ways can I order the 11 pencils on a table? 11 factorial, which equals 39,916,800. A very big number. As you can see, the factorials get very big very quickly because this times this times this. Okay, so that's the most common use. So to explain it, to begin with, I'm going to forget about formulas. I'm going to pretend there are 4 people standing right there. And to make it simple, I'm going to call them A, B, C, D. It's quicker than giving long names. And I produced this chart. Okay, there's 4 locations, 4 places in the line. And this shows all the different ways. Of course, I'm not going to go to this whole chart because it will take so long. But one example, in position number 1, we put person A. If person A stands in location 1, location 2, there's 3 possibilities, B, C, and D. If I just take one of them, we put person B number 2. Now there are 2 ways to fill position 3 with person C and D. And the 4th location, there's only 1 possibility. If we put A in 1, B in 2, and C in 3, there's only D in 4. Okay, got that? So here's just one more, is BCAD is just one other example, BCAD. As you can see, the number of ways of ordering is 4. 4 to begin with. Once you've done 4 in space number 2, there's 3 ways. Space number 3, there's 2 ways, and the 4th location is 1 way. We've got 4 times 3 times 2 times 1. We've got 4 factorial ways of ordering the people, which happens to equal 24. Hopefully that explains, for example, why 4 factorial is the ways of ordering 4 people. That's the most common usage. And it gets complicated with what ifs. What if we're ordering 7 people and persons A and B have to have 2 spaces between them? What if we're ordering 9 people and these 3 have to always be together, etc.? So it gets more and more complicated, but that's the introduction. I'm going to go just one step further. Let's pretend we've got 4 people. Again, for simplicity's sake, the names are A, B, C, D. It saves us time if I just call them that. The only extra twist is A and B are best friends, and they must be together. How many ways? All right. So there's many possibilities as long as A and B are together. What I do is I treat A and B as one concept. Here's A and B, there's C, and there's D. How do I order it? Do I put C here? Do I put D there? And do I put AB there? So one possibility is C, AB, and D. Another possibility is D, C, and AB. Okay, that looks as if there's 3 factorial ways because I'm treating AB as one concept. But there's one other little twist. With each possibility, there are 2 ways of ordering A and B. So I could, for example, say C, then D, and AB, or C and D, then BA. Or I could say AB and CD, or BA and CD. So with that 3 factorial, which is because I'm treating it AB as one concept, we have to times it by 2, because with each order, there's 2 ways of putting A and B. So the correct answer is 3 factorial times 2, which is 1 times 2 times 3 times 2, which is 6 times 2, which happens to equal 12. So if I've got 4 people to put in a lineup, but 2 of them, A and B, have to be together, there are 12 different ways of doing it. And that is the introduction to factorial. And I appreciate your patience, and I cannot wait to produce more videos to teach you more about mathematics. Talk to you soon.